Hi everybody, this is Dr. Nigro. I want to do a quick screencast to show you guys how to use the equation editor in Google Docs so that as we continue to work on our Stoic online, you guys can put your work right onto the Google Doc. Okay, the practice problem we're going to be looking at is aluminum metal reacts with sulfuric acid to produce hydrogen gas and aluminum sulfate. Our first job is to write the balanced equation. All right, so if we go underneath part A, we can type in aluminum metal plus sulfuric acid. Now, there are two different ways to type this in. You can type it in with the subscripts just up as regular numbers, or you can use the shortcut key subscripts. And the shortcut key is hitting the control button and then the comma button at the same time, right? To go back to regular script, hit the control button and the comma button again. And then type in your state. All right, for the arrow, again, a couple choices. We can use some dashes, an arrowhead, or if you like it to look pretty, under the insert menu is a special characters option. If you click there, you'll see all these arrows show up. Just pick the arrow, click it once, and it will drop it right into your reaction. All right, on the product side, we have hydrogen gas and aluminum sulfate. Also a solution. All right, so there's our reaction. Now we need to balance it. If we look on the reactant side, we have one aluminum on the reactant side, but two on the product side. So I'm going to need to add 2 aluminums to the reactant side. If we look at our sulfate group, we have 3 sulfate groups on the product side, but only 1 on the reactant side. So we add 3 on the reactant side, which gives us 6 hydrogens on the reactant side, but only 2 on the product side. So we add 3 there. So you should have a coefficient of 2, 3, 3, 1. Okay? Now, for the actual problem itself. All right, how many liters of hydrogen gas will be produced from 56.3 grams of aluminum metal? The reaction was conducted under STP conditions. All right, so this is a stoichiometry problem where we're moving from one piece of the reaction to another. So there's going to be a mole ratio step. All right, but before we can get to the mole ratio step, we need to convert the 56.3 grams of aluminum to moles of aluminum. All right, this is where our equation editor is going to come in. All right, to use the equation editor, go to the Insert submenu, click, and then drop down to the word equation. All right, you're going to get a new submenu right here on your toolbar, and then a blue box shows up on your screen. All right, to work with the equation editor, you need to be inside of that blue box. All right, so for this problem, 56.3 grams of aluminum times. All right, to put in our conversion factor, we're going to go to this math operations dropdown and choose the A over B fraction option. It always starts you on the numerator, so type that in first. 1 mole of aluminum. Click the forward arrow on your keyboard to drop to the bottom of that fraction. Has a mass of 26.98 grams. All right, once you finish your conversion factor, hit the forward arrow again. That'll take you out of the fraction, but keep you in the equation, the blue box. I just use X for times. All right, now I'm ready for my next conversion factor. I go back to the math operators, click the fraction, and this time I'm going moles of aluminum to moles of hydrogen gas. So I know that 3 moles of hydrogen gas, forward arrow to the bottom, every 2 moles of aluminum metal. All right, now you'll see I just left the 2 for hydrogen gas as a regular number. Just do that. It's too complicated to try to put them in as subscripts. All right, go out of that conversion factor, X for times, last conversion factor. This time I want to go from moles of hydrogen gas to liters of hydrogen gas. I'm under STP conditions, which means I can use my molar volume. So 22.4 liters of hydrogen gas for every 1 mole of hydrogen gas. So I go back and look at my units. It looks like my grams of aluminum will cancel, my moles of aluminum will cancel, and my moles of hydrogen will cancel. So now it's just the calculator. So 56.3 times 3 times 22.4 for the top, and then divide that by 26.98 and divide again by 2. And I find that I'm going to be forming 70.1 liters of hydrogen gas. Okay, so that just gives you a quick overview of how to use that equation editor. I will say the more that you use it, the easier it will become. So I highly recommend that you start practicing, and let me know if you have any questions. Thanks.